SAS class with Amanda. Hey! In this video, we discussed two-way tables. In particular, our learning objective is to define the marginal distribution of a two-way table. Okay, so two-way tables are tables of counts. Often, we have two categorical variables and we want to say something about them, so we can put them in a two-way table where this is categorical variable 1 and this is categorical variable 2, and then we have a bunch of counts, and these would be individuals that fall within specific subcategories of each variable. Okay, so let's look at an example. So here we have a table that describes votes cast for presidential candidates in 2012 in North Carolina. So we're just looking at one state, and we looked at how many people voted for Obama, how many voted for Romney, and how many voted for some third option, whether this was the Libertarian Party or the Green Tea Party. I sort of lumped them all together under third option. Okay, and so we see that the number of votes for Obama are a little over 2 million, but the votes for Romney are also over 2 million, but greater than Obama by approximately 200,000. And the third option, there's no way that person was going to win North Carolina. They lost by a landslide. And here are the total number of votes. This is not the total number of voters or registered voters in North Carolina. This is the total number of votes. All right. So, what if we want to further analyze this data by age category? Okay, so age is going to be one variable, and the other variable is presidential candidate. Okay, so here are our two categorical our two variables. Okay, and the categories that people can fall in for each one. So this is the number of 18 to 25-year-olds who voted for Obama, who voted for Romney, etc. All right, but if we just cared about age, then we would look at these numbers, right? Because here this says this is the total number of 18 to 25-year-olds who voted. It doesn't matter who they voted for. Okay. Why am I highlighting that? Well, because the row and column totals are exactly our marginal distribution. Okay, so the row and column totals. Okay, so the row variable is age. Okay, and so the row totals will describe age. Row totals describe age. And then our column variable are presidential candidates. Column variable presidential candidate. And then our column total, which is exactly the same as what we were dealing with up here. Notice, column total describes the presidential candidate. Meanwhile, these intersections, are the number of individuals that fall under both categories. So one thing to note about marginal distributions is that the marginal distribution says nothing about the relationship between these two variables. So again, the marginal distributions are the row and column totals. So note marginal distributions describe the two variables separately. And say nothing about the relationship between the categorical variables. Alright, so we have seen a two-way table. We can identify what the marginal distributions are. Just note also here is the table total. So you should always add up the row totals and the column totals and make sure that they give you the table total, because the table total should be the same for your total row distribution and your total column distribution. And remember, when we graph categorical variables, either we use a bar graph or a pie chart.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so nil, 1/10. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife. The implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.